So today I'll be talking about value innovation with AI. And to start off, what I would like to say is 5 years ago when I started the company, I had no idea what value innovation was. No idea. I've learned a lot through over the last 5 years, and I know a lot and how valuable knowing the value innovation concept is. But 5 years ago, I came from a very academic background. My life was, tuning hyperparameters, figuring out how to do L2 norm on a new piece of mathematical equation for improving machine learning algorithms and whatnot. That was my life. So I started the company, and then I thought, well, I got to build it. And if we build it, the company will come into fruition and whatnot. I was so wrong, right? Selling is equally hard, strategy is equally hard, besides just writing a piece of code and building a product. Now I know more, and humbled after 5 years of building the company, I will talk about some of the learnings I had, especially in the beginning when I was just trying to do AI from a very technical perspective, and now shifted to the center where there's putting equal value from the technical perspective and from the business perspective, and how luckily, even though I was not thinking about value innovation, we actually were doing value innovation. And as now, the more I look at what some of the things we were doing on the customer service automation side, I realized we were actually doing value innovation. So today, Fuse Machines is about 200 people company. It's in 4 countries, New York, Dominican Republic, Canada, and Nepal, where we have one of the largest operations. We started out with building our first product, AI for customer service. Then we had a second product line, AI for sales. So we have 2 product lines. And more recently, we have started a new business line called AI as a Service, where our mission is to democratize AI by finding talent around the world, grooming them through our training platform, and building teams that we provide to clients, which we call AI as a Service. And that's what we do. So before I delve into a lot around value innovation side for AI, first I would like to start by talking what AI is, right? There's so much hype. When I started my PhD almost 15, 16 years ago on doing AI, no, not a lot of people were talking about AI. Even 5 years ago, when we were giving pitches to the large organization, 5.5 years ago, some of the investors told me, because I think we were still at the transition where AI was about to pick up, but hadn't picked up yet as much. Some of the investors said, don't say it's AI. Tell to some of the customers, it's a natural language dialogue system, because that's what it is. But now we just say AI for customer service. So first, I would like to spend a little bit of time talking about what AI actually is and have a little bit more deeper understanding of it. Then I'll transition into how we ended up doing value innovation with AI on the customer service side. And then I will end the talk with a framework called AI-DR framework that we have developed as we try to do value innovation with AI for large organizations. So what is AI? So any system, any machine that you build that can take input in many forms and do a reasoning on it and be able to do a task that potentially a human could do is AI system. You've probably seen a lot of this. And particularly there's all these words that get thrown around these days, right? There's AI, there's machine learning, there's deep learning, there's data science, there's big data. So how are these all related? Are these all AI? So the way I would differentiate, or the way I would define it is, if you're building a machine, right, that takes and automates one of the 5 senses, speech, touch, vision, and so forth, and you build a system that automates that, that's AI. Like self-driving cars that looks at the road, sees the road, figures out how to take a right, how to take a left, and stop when there's a human, that's AI. But how is AI fundamentally driven? Before, in 80s and even early 90s, that it used to be a lot of rule-based system. Until there was a paper in 1994 by some folks at IBM where they took rule-based machine translation system and said, okay, we're going to completely change it to a statistical data-driven system. And then they were able to show that a completely data-driven machine learning system could outbid rule-based system as well. And I think that's when more and more researcher started to say, okay, let's forget about expert systems, rule-based systems. Let's talk about how do we build more complex mathematical algorithms that can figure out patterns better and automate it. All based on all statistical theory that's been developed for more than 40, 50, 60, 100 years. And that's machine learning. And that's the primary driver for all the AI systems. And there are many different kinds of AI machine learning algorithms. And one of them is neural networks. And neural networks with many, many layers is deep learning. So in a sense, when you hear the deep learning that gets thrown around so much these days, deep learning is just the type of machine learning algorithm, a statistical algorithm that drives AI systems. Now, value innovation. As I told you, 5 years ago, I didn't know what value innovation is. I'll just briefly touch, right? So value innovation, as you heard before in the morning as well, you're trying to create a market where you're creating new value, improving the value, reducing the cost, and not going outside from the place where everybody is competing. And I'm sure that you will see this diagram throughout the day today, where value innovation is, you're trying to improve the buyer value, create new value, or raise the current value, at the same time reduce the cost. The question is, how do we do it? Our more specific question for today's talk is, can we do this with AI? How do we do value innovation with AI? So I briefly talked about AI at a very high level, but I would like to go into a bit more detail on the AI side itself before I talk about value innovation. And as I said before, the key driver for AI is the machine learning algorithms, the statistical algorithms. So if you are sitting in an organization or if you're trying to help a client to figure out how to do value innovation in AI, the most important concept you got to understand is machine learning. And the way I would describe it to understand machine learning algorithms is there are 3 fundamental problems. Pretty much if you take most of the machine learning algorithms, you can bin them or put them in one of these bins. How do I take a lot of data and predict scores? Right? And if you really think about it, a lot of problems is to do that. The scores could mean how good a potential customer is. It could be a lead score, right? So if you build a system to predict a lead score, that's data to scores. The other one is data to classes and data to clusters. So I'll go through briefly each of these. So data to scores is any kind of data, be it structured data, be it unstructured data, where unstructured data could be image data, video data, text complaint data, and so forth, and you come up with a score, and score has a meaning. So now you are thinking of essentially building a machine learning algorithm that sits in the middle, takes this kind of data, and comes up with a score, where scores predict something to automate something, right? It could be predicting sales. So if you like the previous sales data, and you build a data to score machine learning algorithm, the score is predicting, the sales for next quarter is going to be this much. And that could be used in many different ways. It could be predicting the score for the lead. It could be a text complaint data. So especially in customer service world, right? There's a lot of people complaining online, over the chat and whatnot. Still, a lot of the chats don't really get automatically scored in many different organizations. They are collected, that sits in the database, but a lot of people are not really doing anything about it. Can you take all of those transcripts and start scoring them and figure out for anybody new, you automatically score and say, this is an urgent a complaint to take care of, and so forth. So that's data to scores. So AI, machine learning, deep learning, machine learning is the core driver. Out of machine learning, data to scores is one type of algorithm. Data to classes is the other one. So what do I mean by data to classes? So these were the scores, but if you make the machine not to give the score, but a class itself, then that's data to classes. Why is it useful? So for example, a trader could be sitting on the desk, and you could have a news prediction scoring system that predicts these are all the relevant news for your portfolio in the trade, right? Now you could get a lot of news with a lot of scores on it, where the person has to keep scrolling down through, could be a ranked list of relevant score, and say, Okay, this is important, this is not important. But you can have the machine optimized already to just show you what's important, so that you actually don't even have to go through the ranked list. You just see what's important. And that's the slight difference between data to classes, where data could be emails, and it could be a system that flags a compliance violation, right? Instead of you getting a compliance officer getting a list of emails saying this is violation with a score of 0.1 and this is 1.0, you compliance officer only gets alerts when actually there was a violence in compliance. It could be the news that I just talked about. This could be customer service transcripts where it's categorized as angry, and so forth. So that's data to classes. And the last one is data to clusters. And here what we are doing is, if you don't have any labeled data, so in order to build both of the data to classes and data to scores, most of the times, I would say most of the times, not all the times, you need a set of training data. How many of you guys know the concept of training data? Okay, so training data is, if you're trying to build, let's say, a classification system, a computer vision system that would take a picture and say, that's a bottle and that's a glass. How would you build one? The way you would build one is, because as a human, we have figured out, as we grew up, the characteristics of bottle and characteristics of glass, right? The bottles tend to have a cap at the top. The glasses don't. The bottles tends to have different colors because there's all these wrappers. Glasses don't. Glasses tend to be more transparent. So these are some features that we as a human, when we grew up, have already embedded in our human brain to quickly say, this is a bottle, this is a cup, this is a glass. If you want to build a machine like that, you need to take account of same kind of features and give it to a machine, right? So let's say if we try to differentiate between cans versus bottles, that's out there in the front, then one of the most important features that you could use is probably height, right? The cans tend to be short. I mean, there's bigger cans as well. If you buy, large can beer bottles, beer cans, but otherwise most of the soda cans tend to be small. So if you take the height of the can and the height of the bottles and you build a distribution, most likely you'll get a distribution of height where height is shorter, like about 6 centimeters for cans, where the height is about 10 centimeters for bottles. That's the mathematical model. And when you get a new system, when you get a new picture of a can, you just figure out which one is closer to. Now, in order to do that, you need a lot of pictures of cans and a lot of pictures of bottles. And that's what training data is. You take the pictures of cans and say, this is a can, this is a bottle. And as you collect that, that becomes a training data, and you use that for quite a bit for data to classes and data to clusters. Data to scores and data to classes. But data to clusters is when you don't have any training data. You just have a lot of data, and you want the machine to automatically figure out patterns in it and cluster it together. So for example, this is UI of our customer service automation system on the side that was deployed in New York City government, right? And the system, what it would do is it would automatically look at all the data that customer service departments used to use and all the data on the web of New York City government, and automatically cluster them, saying this set of documents is about application, this set of documents is about catering, these are the guides, these are the limousine services, and so forth, without you explicitly saying this document is about limousine service. And that's useful because you don't have to train any data. The machine already figured out all the clusters of documents together and was able to use it. And in a sales world or a marketing world, you could think of it this as, what are the clusters of potential buyers that have a similar features, so that you could bin them in one cohort that could be shown an ad for yellow jackets, because this set of customers tends to like color yellow. So that's data to clusters. And like I said, this could be for customer data, and this could be topic cluster for news. So one great example for data to clusters is Google News. How many of you use Google News? right? And in Google News, every day there is a cluster, and you could click on a site saying expand the cluster, and it will show you all the relevant news. So every day the machine is looking at all the possible news sources and saying these two are relevant, so let me build a cluster without any training data. Any questions so far? Please, you're more than welcome to please stop me in the middle and ask questions. So we just talked about these three things. Let me see if this works. Yeah. Data to scores, data to classes, data to clusters. These are the machine learning algorithms. And there are many different types of them. So if you want to do data classifying system, you could use naive Bayes, conditional random fields, Maxent models, many different types of machine learning algorithms. That's the system, or that's the machinery that's driving all of AI. And one type is a neural network, which is deep learning. And deep learning has particularly gotten popular because, as I was saying before, on how you try to figure out what features we as a human use to differentiate between classes and try to extract similar kind of features to feed to the machine, deep learning got popular because you don't have to decide yourself. You make the machine to decide features. So if you look at image classification systems, deep learning would look at the images, automatically figure out the hierarchical feature representation of it, and then classify it. And what ended up happening because of this famous paper on image classification is the machine was able to detect, for example, features that look like lines that when composed became different parts of your face and then started to look like faces. It was as if machine was trying to understand what the face looked like. And because of that, the image classification system has gotten to a point where the performance, at least in a given test set, is at what we call a superhuman performance. So all the machine learning algorithms before deep learning, when they were being used, even up to 2011, the error rate was almost at 20%. But since the neural network-based deep learning got embedded, it went all the way down, and about 5% is a human performance, which is if you ask a human and give the person 100 images, the person would make mistakes on classifying 5 of them, while machine is actually at 3. So there are some particular problems where machines can do even better than humans in a closed set. Now, with a deeper understanding of AI, obviously as deep as I could get in 10 minutes, but but hopefully I hope it was useful to sort of think of AI from a perspective of machinery that gets actually used to really build it rather than just talk about AI. Now let's talk about value innovation, but with AI, right? And one of the things that AI is super useful is AI can bring automation. And a lot of times, AI automation can reduce cost. And not all the times, but many times, automation can increase buyer value as well, right? And if you are sitting down trying to think of how to do value innovation with AI, you should first think about also what kind of problems are there where it is possible to do some level of automation. And this is a graph from McKinsey where they say, what are some of the tasks that are hard to automate versus what are some of the tasks that are easy to automate. So you should try to figure out from the perspective of how difficult it is going to be. And some of the task is going to be super difficult, right? Like trying to create a psychiatrist or legislator with a machine. Probably is very hard versus trying to do some automation on predicting which destination you might want to go and optimizing travel tickets is probably easier to do. So first you have to figure out where in this automation difficulty level the problem sits, and then decide if you can do it or not, and decide if it's worth it or not. And what I would like to do is, going back to 5 years ago when I started Fuse Machines, how we ended up doing value innovation with AI without me actually knowing that we were essentially doing value innovation. But now, as I understand it, it was a value innovation. So, five and a half now, years ago when I was sitting down to figure out, okay, I've been in academia way too long. I mean, I still teach, but lot less now. And I was trying to sit down and figure out, okay, what is it that I should try to build a company? And as I said, I was an engineer, so first thing came to my mind was building a product. But what kind of product? And my PhD and all my life, I'd been doing natural language processing, AI for NLP. So I said, well, let's try to see where can I find a problem where the impact could be pretty big if I'm able to automate a few things with natural language processing. And the problem I ran into was customer service interaction. Apparently, just in the US, about 4 billion calls are made, 4 billion calls or requests or tickets are made every year just in the US. So imagine customer service centers, the volume they get on the request from the customers, right? So I said, well, that's a good problem. That's a big market size. And from the data perspective, a lot of data is already logged. So why we should try to improve this and make the experience better so that, people are not shouting over the phone. Now, the question was, at that time I was not asking this question, but the question was, how do we reduce cost and how do we improve value, right? So if you want to reduce the cost from the customer service side, you want to fewer customer service agents, because customer service agents are one of the most expensive part in the customer service departments, in the call centers. And you also want shorter calls. If the customer service rep spends 1 hour, that's not good, right? You want the customer service reps to be able to answer the queries and resolve the tickets as soon as possible. If you do that, then the customer service rep will be able to take a lot of calls, and the calls will be shorter, which means they can perform better by processing more calls. So that will reduce cost. In order to improve buyer value, in order to not get to this point, I mean, a lot of people get to this point, and I have gotten to this point many times because the call wait time was like 50 minutes, right? Like I used to have, not to talk bad about RCN, but I used to have RCN, and there were times when I was on call for whole time for 50 minutes. And the problem with that is you have the phone on the hand, you don't really want to give it up because what if the customer service comes right when you just turn it off, right? You don't want to give that up. So, but you're just waiting, you are trying to do a few things, but your mind is still on the phone and so forth. So how do we try to improve the wait time that will improve the buyer value? And those are shorter wait times. Wouldn't be amazing that any time you call a call center, they just pick it up and then you don't have a line at all, right? That would definitely increase the buyer value. And shorter calls. You called, you said, oh, I have this problem. The person just does whatever the person needs to do, and it's resolved. That would improve the buyer value. So how do we do that? So we said, well, at least from the phone perspective, from the speech recognition perspective, at least 5.5 years ago, speech recognition was not where it is today, right? The speech recognition systems are notoriously perform worse as the noise gets bigger, as the noise gets louder. And particularly over the phone, because a lot of phone signals are clipped at 4,000 kilohertz. Because of that, there's a lot of signals that gets lost when the data comes all the way to the data centers for processing. So which meant, at least on the phone side, trying to do automation at the voice level, we thought it's going to be hard. There's a lot of a lot of other parties also trying to do things on the phone to improve the call center over the phone. So what we said was, okay, let's not try to compete in that world where it's much harder to make it work. Let's try to work at a completely different channel where we don't have to deal with the phone errors. There's less competition, and there's a lot more competition now, but this is 5.5 years ago, right? We said, okay, we'll do chatbots. And at the time, the messenger didn't even allow bots and whatnot, but now they do. So it was mostly through a website and SMS. A lot of it as a website. So if we try to build AI like that, it would reduce wait time because it's a machine. There's no wait time at all. So there's a buyer value increase. And for a lot of people, it's more convenient. I don't know how many of you use the widgets on Verizon or whatnot, where in the beginning, you might get a machine to take basic information, and if it looks like you're frustrated, it would transfer to human. And the beautiful part there is, as you are working, you're just chatting as if you were chatting with one of your friends. You're not on hold for 50 minutes. And then there's a reduced cost, right? Because especially if the machine is able to do a big chunk of the work in the beginning, to take the problem, to take what your account number is, whatnot, a lot of the work is already done for agents. And especially account numbers and addresses. Over the phone, for some agents, sometimes it's hard to hear because of the phone signal and whatnot. But here, you're just typing it in. So they have exactly the account number without a lot of errors and whatnot. And preliminary questions already filed. So that's what we ended up doing. We ended up doing value innovation on customer service side without actually realizing it was value innovation. And that is probably one of the reasons now, when I look back, we were able to get pretty big customers right in the beginning. Our first client was New York City government. I mean, governments are notoriously hard to close. And we went live within the first year of building the product on end of December in the Bloomberg administration with a chatbot, our product, live on New York City website. And that's what this looked like, right? You could start typing a question. It would answer questions. It would also give you recommendations on what other things you might be asking. And we learned a lot, right? In the beginning, we said we'll try to do a full automation without having humans involved. 5.5 years ago, technology was still not there, and we saw a lot of angry customers where, machine wouldn't really get it, but machine would keep asking questions. So the complete machine version, we translated into what we called at that time a human-machine system. It's more common now, where the machine would ask a bunch of questions, try to answer the questions and whatnot. And at some point, when people start shouting or people start saying nasty things, it will just transfer to humans, and then it stays at humans. And there were a lot of other optimizations we had to do. So what we did was when the person gets frustrated, it gets to transfer to human. The human would answer it. The chat would again come back to human, and the human would continue. But there were a lot of times when human got hit another point where they were frustrated and got transferred to to human again. At that point, the second customer service rep who was trying to serve in the same chat had no idea what was going on. So it was more time consuming to read all the context and whatnot. So the final system that ended up doing pretty well was a machine system that would try to answer as many questions as possible. When it detected frustration, it would transfer to human and never come back. And it worked well. And we were able to sell it to other banks besides the government and whatnot. And there are many other places to think about where you could do value innovation in the customer service side. Many. Now, the next question that I would like to answer is, how do we find opportunities for value innovation with AI in an organization, right? Like I said, if you look at this example, there's a lot of places where you could automate stuff. Automated response, or rank automatically channel preference, predict product purchase, like many things. But big question is, if you're sitting down, or if you, for your organization, or you're trying to help an organization, what are some of the questions you need to ask yourself to figure out where can you find value innovation with AI? The way I would frame the problem is, I would frame it in a problem what I call AI-DR framework. So basically, this is the framework that we came up with that we thought is quite useful as we built more and more AI products for other organizations and ourselves. The AI-DR framework, A stands for algorithm viability, I stands for impact on revenue or cost, D stands for data, and R stands not for revenue but recurrence, right? Revenue is already taken out of here. So let me go through AI-DR and how you can think of any problem that you're trying to understand in your business organization and how to think it from the perspective of AI-DR. So algorithm viability, what do I mean by that, right? So there are algorithms that make some things close to reality, but there are a lot of things, a lot of problems where the algorithms or the research in machine learning is not at a point here where it's close to reality. So if you're trying to build a psychiatrist, that can talk fluently and just understands everything and have a very long 1 hour conversation with you and become buddies, maybe that's not close to reality yet. We have chatbots, simplified chatbots, but not to a point where natural language processing research makes that possible. While, autonomous cars is getting more and more real. So if you're sitting down trying to figure out, you should think of what are the available algorithms out there that's already been applied to a similar problem, and what is the accuracy of it? And is that accuracy enough for you from the business perspective to be able to apply it? The second one is impact, right? Does it really impact cost or revenue? I think this is pretty clear. The third one is data, and this is super important. Especially for large organizations, data resides on multiple servers, multiple organizations, multiple red tapes. If you're trying to do the value innovation with AI, because building machine learning systems does require a lot of data, we as humans is able to take few samples of data and able to create coherent learning framework and decision-making process. But for machines, it does require a lot of data. So is there enough data? Is one of the big questions. And is there the right kind of data? Is another big question. And if you have unstructured data, how much unstructured data you have and how to process the unstructured data, and all those questions related to data. Yeah.
So you say generate data. So you're saying the training takes place from the data the system itself is creating versus more data from its original source?
Not from the original source, but what I have seen is the most successful AI systems are those where once you implement it and users start to use it, it generates data that can be fed back to the system.
So just like, in other words, positive and negative type of, it matches, did its job type data? It was the classification, it classified right or wrong.
Yeah.
That type of learning.
Yes. So to give you an example, so we have a sales AI assistant for sales that plugs into your Gmail, reads all your email, and every morning it sends you one email saying, these are the 10 most important people to follow up, particularly from sales perspective, right? Now, if somebody follows up with the people in that list and follows up with 6 people, then the machine is able to take account of that saying, oh, I predicted these 10, 6 were actually important and the person followed up, and the 4 were not. And that becomes another set of data to retrain the machine itself the next day so that it starts to become custom AI system for you, right? There's no customization in the code, the machine is learning. And in order to machine keep learning from the user feedback, you need to figure out, is there a possible way where you can design the system and algorithm such that it generates the data? And the last one is recurrence, which is if you automate something that you do once a year, maybe it's not that useful. But if you're able to automate something that somebody does every hour or every day or multiple times a day, then there's a lot of value to it. Identity confirmation and so forth. And as you do it, as I said, besides thinking of the problem in the ADER framework, you should always think of it from the perspective of on the difficulty level of automation and see where you stand. Because the more cognitive system, the more complex cognitive system that you try to emulate that human does, the harder it is. But the more simpler repetitive task you try to make machine automate, that's what we end up doing. And that's value innovation with AI. Thank you.
Any questions?
Oh, hey.
What? Voice activate.
There we go.
Yeah, thank you very much. That was very informative, and I liked how you framed it from machine learning into some of the newer applications. My question is on your ADER framework. If you were giving recommendations to a company that was, let's just say they were just gathering initial user information and providing direction on applying certain frameworks, but they had an idea that they might want to move forward and implement AI in the future. But they were just trying to build kind of a basic user interface database at this point. What recommendations, if any, generalized, would you give to such a company?
So if somebody is at a stage where they're trying to build a product, so if I'm understanding the question correctly, they're trying to build a new product potentially, and they know at some point they might use AI, but right now they're not really doing it, but they want to make sure that if they want to use AI, everything is in place, right? Yes. So there's no technical baggage, essentially. So if somebody is in that stage, one of the most important part I would say is the data part. Where you don't miss out on any data that could potentially be useful later on. So what I would tell the potential client or whatnot is sit down as you design it, think about if you were to automate it with AI, what it would look like. And if you were to build a machine learning system for that, what are all the data points that you would need for that particular automation? And then work backwards so that even though you don't use it right now, still gather those information.
As you said, the world is rife with buzzwords. It's sort of a two-part question. One is, there's talk about RPA and, robotic automation and then the AI. Can you talk about the overlap, distinction that might apply? First question. And the second was, is this mature enough that there is sort of a standard set of applications that are used for implementation, and just what might some of those be, just out of interest?
So RPA, robotic process automation, there's quite a few companies doing it at this point. Is mostly the applications where the system records what you do and then try to replicate it. At least in some of the videos of UiPath, Automation Anywhere, like when I look at some of these companies' videos of examples of the product, I don't see a lot of AI yet. They are more of a software that can track everything you do and redo it for you. But I think it's slowly moving towards adding more AI on it. And they are calling it cognitive process automation, right, with AI on it. So I would see, from the trend perspective, you would see more and more AI added on top of RPAs to make it more AI-driven that can make decisions, more complex decisions. And one of the places is, like, for example, handwriting recognition. Where handwriting recognition, the OCR to figure out, documents and whatnot is easier, but handwriting recognition is notoriously hard. And now we're getting to a point, especially because of machine vision improvements on the learning algorithms, it's gotten to a point where you could do it pretty accurately. As far as the second question is, what are some of the applications that are probably at a cusp of, seeing fruition if you apply AI? I would say customer service is definitely one. Sales, there's sales predictions and things like that. I think there's more that will come out of it, especially where people are looking at the audio and then doing prediction on, what kind of audio, what kind of behavior on phones for salespeople translate into real sales. A lot of computer vision applications, because particularly on machine learning world, machine learning applied on top of computer vision data versus NLP data, language data. Language is notoriously hard. So at least on the vision side, image classification has already gone beyond human performance. So image classification systems and so forth.
So it seems to me in the AIDR that recurrence and impact on revenue and cost are what my attorney says are business decisions.
Yeah.
This is kind of a chicken and egg question. Does the algorithm viability come before figuring out the data you need, or does the data determine the viability of how you build the algorithm?
Data is equally important, but if you were trying to decide, I would first think about the algorithm viability.
So here's a specific example from my world.
Yeah.
I get asked once a week, does your website let me identify trees? And the answer is no. But they email me and I try to identify the trees for them. So I have the recurrence. But I can say that's a maple, but I can't say it's one of the 130 species of the maple. I can tell them it's a can, but I can't tell them what's in the can, like your cluster example.
Yeah, so if you were to trying to apply AIDA framework there, first, when I say about algorithm viability, I am talking about, is there a machine learning system or the algorithm at a point where is it able to distinguish very nuanced differences on trees? And if somebody has not built exactly on trees, maybe there might be a research paper out there that talks about very nuanced differences between bicycles or cars, right? And if that's possible, then you know, okay, I think I can, the system is, from the research perspective, it's at a point where you could do it, but you don't have the data for all the different kinds of 130 different kinds of maple tree. Now the question becomes, do you have data to train to identify 130 different types of maple trees? And at that point, you need to figure out how to get the data for those 130 different types. So in that case, algorithm viability, it's viable, but from data perspective, it's a big question mark.
Good morning. How are you?
Hi.
I assume when you engage in a project or initial stages, data cleanliness, data integrity, and figuring out what that is I would assume highly important. Do you have a specific process that initially going into a client that you perform to figure out exactly how that works?
There's no exact process, I would say, but if I were to think of from the big buckets on what we need to do is first is the data collection, where you are able to bring all the data together, and the second portion is we're able to intersect the data across multiple things. And then if it's unstructured data, how do you clean it? Because if it's email, then there are a few things that you need to do to clean it. If it's web data, then there's other things that you need to do to clean it, and so forth.